If you want to render equations or code blocks in Blender, then this tutorial is for you. I've recently published the Typst importer extension in the Blender extension store. You can get it for free and it's available for all platforms. In the next few minutes, I will show you how to use it, and we will go over the Python API, and I will show you how to render scenes like these. First of all, let's have a quick look on Typst. So here you can see Typst. It's a typesetting language similar to LaTeX. So you can render these kind of mathematical equations, you can render tables, and they claim it's easier to write than LaTeX. And from what I've seen so far, I think this claim is quite valid. You can also go to their internal code editor, and I really like how fast this is. So you can enter formulas, and on the right side you will get the updates for the formula rendering in real time. Let's minimize this editor and go to Blender. Here I go to Setting, search for Typst. Here you will see an installation button. You click it and within a few seconds you will get this extension. I already have it installed. And now there are two ways to use it. The first way is to just drag and drop Typst documents. So for example, here I have a Typst document with some code, or here I have one with a matrix. So let me drag and drop, or drop this one a bit up. And now I can import this one here as well, and this is now my equation in Blender. But there's another more elegant way to import Typst data, and that's over the Python API. And when I press enter, we have the formula here. To show you some more examples, I'm now opening a Python notebook in the code editor Cursor and show you some more examples on how to use the Typst through a notebook. First, I add some helper functions, for example, this load paper background function, or a function to set up a new scene, and this scene to render the result. They are very specific to Python notebooks, so don't worry too much about them for now. What matters now is these equations. So when I run this cell, I render the equation in the viewport. I also get the equation here, and I can make changes to them, and the camera will update accordingly, and the render will also update accordingly. The nice thing about Typst expresses is that it returns us a collection. So this collection called integral. And when I render the result, I can say, okay, I want to render this collection, and the camera will be placed automatically at the right place. I can also change the name to hello, and I will see, okay, this updated it as we wanted it to be. Next, we will have a look at some more function arguments. So here we have Einstein's equation, and for example, we have a scaling factor. So right now the equation is quite big. When we want to have it a bit smaller, then we can just change this parameter. And this is because the original Typst content is quite small. So it's a matter of pixels, which is the normal scale of the text. But in Blender we sometimes have bigger scales, so this is just a parameter to control for that. Then these two parameters I will show you in the next example. So here I have an integral with 9 curves in total, and these elements all have their origin at 0, 0, 0. But sometimes I might want to have a better control and set the origin somewhere else. So I can say origin to character, which is false by default. I can now set it to true. And now I have a look again, and these objects now have their origin at their individual geometry origin. Another useful thing you might want to do from time to time is to join all these curves into one curve, so it's a bit easier to work with. And for that I can say join curves equal true. And now when I press this one again and drag it, I can see it's actually only one curve. Another nice thing about this editor called cursor is that I can also make changes to the code via AI. So I say I want to have the integral of g of u. I say generate, and I say accept and run, and it updates the integral accordingly. Okay, and now I say, now I want new boundaries. And it also gives me new boundaries. Oh, the infinity. Okay, it doesn't know Typst too well, but in theory it should work. Here is another example with colored equations. So sometimes I might want to set this k variable to the color orange, this n variable to the color blue, and after setting this up I can render the result and it's colored. In this example I have symbols which are not very common, for example this nabla operator or this integral, and Typst also has support for these. Sometimes if things are not rendering correctly, it might be useful to also have a look at the underlying SVG, and this is where c.processed_svg comes in very useful. So when you access this element of the class, which was returned by Typst express, then we can print this string, which is the SVG, which is rendered here in Blender, and we can even display the SVG as an object in our Python notebooks. And that's sometimes very useful when you have here something that doesn't look right and you want to see, okay, is it a problem with Blender? Is it a problem with the SVG? And yeah, this is a very nice, useful debugging tool. Last but not least, here's two examples on how to render code blocks. And finally, I have here an equation to render a matrix. If you want to replace the matrix with something else, you can also anytime go into this Typst editor, copy content, go back to cursor or to your Blender IDE, paste the content here, and when I run this one again, it will also immediately update. I hope you find this tutorial useful, and if you want to play with these examples yourself, you can all find them here on this link, and see you next time. Bye.